Hello everyone. First and first, make sure you share this video to other people. In this tutorial, we are going to provide a solution to these four interesting logarithmic equations. The first equation is 2 multiplied by log of x with the base of a minus log of x minus 1 with the same base a equal to log of x minus 2 with the base of e. Before we start, you should know that the argument of a log function will have to be a positive number greater than 0. Therefore, x here will have to be a positive number greater than 0. And according to one of the laws of logarithm, this number here before the log can always serve as the power of our argument. And because we have subtraction, whenever you are subtracting two logs of the same basis, you see, a, you are free to take a log, then you divide the arguments from left to right. So let's get started. We're going to take this and divide by this, but remember this is x squared because this 2 will have to serve as a power of x. So we have log of the whole of x squared divided by this, which is x minus 1, right? Equal to log of what? X minus 2. All of them having the same basis. And since from left to right we have common basis, we can equate the arguments, right? Which implies that this must be equal to that. So we have x squared divided by x minus 1. This is equal to x minus 2, right? So we can cross multiply. You take this, you multiply by that, right? Already we have x squared here. So we have x squared equal to this times that. We have x times x will give us x squared, right? Then you can add the constants. -1, -2 will give us -3. Then you attach x, then you multiply the constants. -1 times -2 will give us +2. Subtract x squared from both sides. You have x squared minus x squared is 0. X squared minus x squared is 0. We only have minus 3x plus 2. You can take this one to the left. It becomes positive 3x equal to 2. Divide both sides by the coefficient of x, which is 3. You have x equal to 2 divided by 3. And 2 divided by 3 is indeed positive number greater than 0. And hence, this is the solution to the first problem. Now let us move on to the second problem. All right, the second problem, we have log of x squared plus 1 minus log of x squared equal to 1. The same thing, since we have subtraction, we are going to divide the arguments. So you can simply take the first argument, which is x squared plus 1. You divide it by the second one, which is x squared, having the same log, right? To which base? Okay, no assigned base, which implies that it is in base 10. This is equal to 1. Then from definition of logarithm, the argument will be equal to that base raised to the power of this number. So the whole of this x squared plus 1 divided by x squared is equal to 10 raised to the power of 1. The base, which is 10, raised to the power of this number 1. From here, you can cross multiply. You take x squared plus 1 equal to x squared times 10 is 10x squared. This is the same thing as 10x squared minus x squared equal to 1, right? And 10x squared minus x squared is 9x squared equal to 1. You divide both sides by 9. Therefore, x squared will be 1 divided by 9. So I want to take square root of both sides directly. So x will be plus or minus the square root of 1 divided by 9. Square root of 1 is 1, square root of 9 is 3, which means that x is equal to 1 divided by 3. Why do I neglected the minus sign? Remember our x. No, yeah, it can be plus or minus. Let me show you why. Because x is to the power of 2. Whether it is negative or positive, the power of 2 will transform it to positive. Therefore, both plus and minus 1 over 3 will satisfy this equation. If you like, you can test it. Let us move on to equation number 3. Equation number 3 is a quadratic equation in terms of log of x with the base of 3. Just observe. I can confidently replace log of x with the base of 3 with y. So it becomes y squared minus 6y plus 9. But I'm not going to do that. I'm going to treat it as it is. This is a perfect squared quadratic equation. Why? Look at this number here. It's minus 6. Half of minus 6 is negative 3. Negative 3 squared is 9. Therefore, this is perfect. And how do we factorize it? You can take log of x with the base of 3. Then half of this is minus 3. Then you square everything. This is equal to 0. The left-hand side is just the factored form of the left-hand side of this. If you expand this, you have to get this back. By taking square root of both sides, it implies that log of x minus 3 with the base of 3 is equal to 0, right? You can take this one to the other side, it becomes positive, which means that log of x with the base of 3 is equal to positive 3. Then x is what? X is equal to 3 raised to the power of 3. This 3 times raised to the power of that 3. 3 times 3, 9 times 3 is 27, which implies that x is 27. Boom. The last one, we are asked to solve log of y with the base of 2 equal to 3 minus log of 4 raised to the power of 3 over 2 with the base of 2. One thing you should remember again, log of a number having the same base as the number will be equal to 1. Log of a base a is equal to 1. So since we have a constant number here, we can multiply by 1. We have a base 2 here, so we can multiply this number by log of 2 base 2. So the left hand side remains log of y base 2. This is equal to 3 multiplied by log of 2 base 2. Log of 2 base 2 is 1 times 3 will still be equal to this 3. And we still have minus log of 4 raised to the power of 3 over 2. I would like to simplify this. Remember that this 3 can serve as the power of this 2. And 2 raised to the power of 3 is 8. 2 times 2, 4 times 2, 8. So this is log of 8 base 2 minus. What is 4 raised to the power of 3 over 2? It is the same thing as square root of 4 to the power of 3. Square root of 4 is 2. And 2 raised to the power of 3 is 8. So we have log of 8 here. They are exactly the same, so they will give us 0. Therefore, log of y with the base of 2 is equal to 0. It's equal to 0. So from definition, y is equal to this 2 raised to the power of this number 0. Hence, y is equal to 1. Yes, so we are able to solve all of these problems. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.